All right, last video timed out, and unfortunately, if you're trying to finish this last reference rule for quadrant 4, you missed it, so we're just going to finish it real quick. Tori, could you please tell me the reference rule for quadrant 4? 360 degrees minus theta. So in our particular case, it's 360 minus 300, so our reference angle for this example is 60 degrees. Let me explain to you right now, everybody. That 60 degrees is right here. This is where that 60 degrees is located. Okay? So if theta, remember, theta went from the initial side to the terminal side, so it rotated counterclockwise all the way to the fourth quadrant. The 60 degrees is this part right there. Okay? What we're going to do now is we're going to go ahead and do problem number 9 together. So what I want you to do right now is make another Cartesian plane. I want you guys to visualize where does it begin and where does it end. Where does it begin and where does it end? So we have x, we have y, we have 0 degrees, 90 degrees.
Are they the same every time?
Yes. And, well, yes, if you're going in a positive direction. And 270. We always start at the exact same place right here on the x-axis. But if you go 472 degrees, you actually go a whole rotation more than what you go a full revolution, right? And then an additional part more. That's the part that you need, is the additional part. Okay, so what you have to do is, when you have 472, the first thing you need to do is you need to realize, ooh, I need to take 360 degrees away from that and understand that I have an additional 112 degrees that I need to travel. So here's what's happened. You started right here on the initial side. You went one whole rotation, which is 360 degrees. Okay? And after you've gone 360 degrees, you have to go an additional what? 112. So that's 90. So 112 will probably be somewhere in here. Okay? So right now I need you guys to understand that from here to right there, that's theta. Theta for us is 112 degrees. Because what does theta have to be between? It has to be
90 and 0.
No.
Oh, 0 and 360.
Yes, 0 and 360. So it has to be between 0 and 360. Well, 112 now fits in between 0 and 360. So, by the way, where did we finish?
Quadrant 2.
Right, so one of our answers for number 9 is our terminal side is located in quadrant 2. That's one of your answers. Okay? It says if each angle is in standard position, determine a coterminal. What does coterminal mean? An angle that finishes at the exact same spot. That is between 0 and 360. What I need you guys to understand is 472 degrees and 112 degrees are coterminal angles. They finish right there. So one of your answers is, it finishes in quadrant 2. The other answer is 112 degrees. That is a coterminal angle with 472. Now, what did this not ask you about? This did not ask you about a reference angle. Well, what if I said, what is the reference? Since we're doing this in your journal, what would the reference angle be?
60 degrees.
Say that again?
68 degrees.
68 degrees, because you have to do what? You have to take 180 minus theta, which is 180, minus 112 degrees, which gives us 68 degrees. Now this question, Jordan, this question didn't ask us for the reference angle, but if it did, it would be 68 degrees. So remember, this rule, everybody, this rule right here, just works for which quadrant? Quadrant 2. Now let's go back and look at the other rules. The rule for quadrant 1, everybody, is just whatever theta is, That's your reference angle. There's your rule for quadrant 2. Here's your rule for quadrant 3. See how they're kind of, that's 180 minus theta, this is theta minus.
Oh, so whatever we wrote down for reference angle.
That's your rule. And the last rule that I forgot to highlight, here's the last rule right here that I forgot to highlight, is 360 minus theta. This is the rule for quadrant number 4. Okay? Now, for number 9, this is your answer for number 9. Okay? This is your answer if I asked you for the reference angle. Let me highlight where that would be. This would be right here. You guys remember what I said? The reference angles are always in relationship to? They're always in relationship to the x-axis. They're always formed with the x-axis. Okay? Never the y-axis. Okay? Now, let's look at number 10. Number 10, now we're dealing with what? Negatives. By the way, when you guys go to college, you might be dealing with negatives. In your bank. Unless you're Victorian, you got a scholarship. Alright, so, negative 995. Now, we start at 0. So everybody, we're still starting at 0. Right there. But now we're not going positive, we're going what? Yeah, negative. So, by the way, everybody, would you agree negative 995? If I went a negative 360 twice, that gets me where? At a negative 720.
Got about 275 left.
Well, let's see. Let's see what we have left. What I'd like you guys to do is take negative 995, and I'd like you to add 720 because we've already we can go 2 rotations. What do we have? Negative 275. Now, here's what I want you guys to do to label this. Label this. Here would be a negative 90 degrees. Here would be a negative 180. Here would be a negative 270. Just 5 degrees past that. Which quadrant would we be in? We'd be in quadrant 1. Very good. So here, if I go an additional 275, just barely past it, right? Just barely past it. So now, I want you to understand is right from here to here, that's negative 275. By the way, everybody, that's not theta. Because theta can't be negative, can it? Huh. What's the distance, or what's the degree from here to right here? I'm going to highlight it.
That would be your theta.
That would be theta. This would be theta right here. This would be theta. Sneaky, sneaky. Hey, it's a good thing it's not recording. Oh, wait. All right, so what is my theta? If that's going, if I'm only 5 degrees past right here. Nope. It's going to be a positive number.
265.
Nope, positive number.
It is positive.
What?
You're right, that is positive.
Yeah, 265 is positive.
Okay, hold on. You guys ready?
Just math teacher.
I'll make it a little bit easier. Here we go. Make it a little bit easier. What angle am I attempting to draw right there?
That's a 9.
Okay, 9.
Is it 85?
Yes.
Oh.
Yes.
Sorry about your example.
Thanks for ruining my example, Jordan. So if that's 5 degrees, if that's a 5-degree sliver right there, we know we went past 5 degrees, that means this angle right here has to be 85 degrees. So our theta is 85 degrees. So by the way, Tori, where did this finish? You said it finished in what? Quadrant 1. And what is a coterminal angle with negative 995 that's positive? 85 degrees. By the way, here's a trick question. What's the reference angle for this? I know, but if I ask you what's the reference angle?
Oh, yeah.
85 degrees.
85 degrees. Because we're what? We're in quadrant number 1. And when we're in quadrant 1, the reference angle in quadrant 1, the reference angle in quadrant 1 is always whatever theta is. Okay? By the way, understand, more students, everybody.
Hey, is the answer quadrant 1 or 4? What's the answer on the paper?
Number 10, quadrant 1, and the coterminal angle is.
Okay, that's what I got, but I was
Okay.
kind of confused with the other thing.
1 second. What I need everybody to understand is whenever you finish in quadrant 1, your theta is also your reference angle. Okay? Now, your job right now is to figure out the reference angles for these two right here. They're both positive numbers, okay? So your reference angle, it should be pretty easy. I want you guys to do the same strategy, and I want you guys to find your reference angle for these.